Hello, fellow Scratchers! I simply love level editors. Almost every game I've created has a level editor built in somewhere. There's Apple, Eat the Level, Paper Minecraft. Well, the whole game is a level editor, right? But even my 3D laser tag game has an editor hidden away inside. So it's no surprise that our Scratch RPG is to feature one too. Without it, designing large, epic levels would be so very hard. Yes, we've got loads of cool stuff to learn, but in this episode we'll include using the pen to paint a nifty split-screen user interface. This is looking so good, right? Snapping to the level grid and calculating the exact tile under the mouse cursor. Displaying a ghosted copy of the active tile brush, that's the one we selected to paint with. And then we'll cover placing or painting new tiles within our levels. So do stick around until the end of this video to see all this and more. But enough talk, guys, let's get scratching. Load up your projects from episode 3. Yeah, looking great. And so as not to lose all our epic progress, we should begin by saving this as a new copy. For this is RPG Tutorial Episode 4. Oh yes, this is going to be fun. The first thing we want is a way to toggle our level editor on and off. And since the editor will need access to all the tile costumes, we'll click into the tile sprite for this. When 0 key pressed. I often use the 0 key to toggle my level editors. If you don't want every user to have access, then you can either remove this script later on, or you could add a user name check, so only you can access it. Now an if-else. And drop in a greater than operator. We need a new variable to keep track of whether we are editing the level or not. Let's name it editor for all sprites. Now, when editor is greater than 0, we are editing the level. So to toggle the editor off, set editor back to 0. Else, we are not editing. So set editor to 1 to toggle it back on again. We can just test that by tapping the 0 key, and we should find the editor variable happily switches between 0 and 1. As an enhancement, let's hide the editor variable when the editor is not enabled. Hide variable editor. And conversely, show variable editor when it's active. Nice, that works well. So all the level editing scripts need to hang off somewhere, so find the when I receive paint background script. We'll paint the user interface after we paint the background, but only if the editor is enabled. If editor is greater than 0, then we'll make a new custom block for this, naming it paint editor, and run without screen refresh. As with the painting of the level tiles, these scripts must run very fast, within one game tick. Pop that into some free space, and we'll make use of the new block right away when the editor is enabled. Here. Splendid. Are you ready to rock? The first thing we'll do is highlight the tile under the mouse cursor. If you take a peek in our costumes, you'll see costume 2, named Outline, is designed for this purpose. I drew this to perfectly surround our 16 by 16 tiles. Hence, it's 18 by 18. So for starters, try switching to the Outline costume and simply going to the mouse pointer. Then, because we are not using clones, stamp the Outline costume right here. Great, tap the green flag and check out what we have accomplished. A very pretty cursor outline that follows the mouse, but what's wrong with this is that we really want the outline to be snapping to the underlying tile grid, not smoothly gliding around like this. Well then, we need to know which grid cell the mouse is over. The trick to remember is that we are viewing only a small window into our larger world map. To get our mouse position in world coordinates, we must factor in CamX and CamY. So for the time being, move these painting scripts over to the right. And now in our variables, we already have a GX and GY variable. We can use these. These stand for GridX and GridY, so make them visible on the stage while we work this through. Set GX to, and we'll sum MouseX with CamX. If we run the project, you'll find this usefully now shows GX as 0 at the far left of the map, rather than the negative 240 we are used to. The player is at 240, And as we walk to the right, GX gets bigger and bigger, which is just what we'd expect. But to find out how many tiles across we have gone, rather than pixels, we need to divide this by the tile width. That's right, divide the whole thing by 32. Of course, as often is the case after dividing, we are left with a fractional number, and that should be cleaned up using a floor operator to round the number down. Carefully drop the entire expression into the floor, and now beginning at 0, we have a beautiful readout of how many tiles across the level grid the mouse cursor is positioned. Let's do the same for up and down, setting GY this time, and we swap mouse X for mouse Y, and cam X for cam Y. And there we go! As you might imagine, this GX-GY grid location will be super useful going forwards. Now that we know the grid location of the mouse, let's use it to snap that outline to the tile grid before we display it. Set X to. We need to multiply the grid X back up by 32, our tile width, to find its position on the full map. Then, to position it relative to our camera, we subtract cam X. But one last tweak, we add half a tile width, 16, to account for the centering of our costumes. We now do the same for the set Y, only with the GY variable and the cam Y variable. Cool, that's the positioning. We just need to bring back the switch costume to outline and the stamp block. Make sure to remember to remove that go to mouse pointer now, we mustn't leave that in. Guys, it's time to smash that green flag. Will the outline snap to the grid? Oh boy, yes, that's much better. And importantly, if we edge the player along, the grid snapping perfectly follows us and isn't fooled by the camera offset. No siree. There's something very satisfying about walking around with the grid aligned cursor. Very professional indeed. Next up, we'll want to get level editing and place down some new tiles. If mouse down, then. Now we want to replace the existing tile under the mouse with a new tile. So we use the replace item of grid block. We need to choose what tile costume we are placing. Something a bit fun. Yes, 118, this big stone. So replace item of grid with the tile costume 118. But which item of grid? We have the grid X and grid Y, but not the grid index yet, and that's what we need. So we need to calculate that. Set GIDX, grid X, to, and do you remember this calculation? The first item is a 1, and then we sum this with GX, our grid X. Now, that is how many tiles across the grid we need. Then, to add the vertical, we need to add, and for this we need a multiply block, because for every tile up the grid, GY, we need to multiply by G max, the number of tiles in a row. Great. So sum them both together, and that gives us the grid index, GIDX, and now we can drop that happily into the replace item block here. Well, this is exciting. Smash that green flag, and it's time to get clicking. If everything has gone well, then we should have placed our first tile, and the first of many, I can assure you. We can make some pretty cool looking walls by just clicking and dragging in straight lines. Oh yeah. Right, I'm getting carried away though, and before you go to town making some ultra snazzy maze, don't forget that as soon as we hit the green flag, boom! Our beautiful creation is gone because the level resets. So, before we get around to adding level saving and loading, the best option would be to click into the level store sprite and simply separate off the new map block from the when I receive load scene. This means that when we run the project and lay down some funky level, the next time the project is run, our level stays just as it was. Wonderful. Of course, there are times when you may still want to reset the level, and then, well, just pop into this sprite and click the new level block, and the level resets. Okay, click back into the tile sprite. Let's expand things so that we can place other types of tile other than just this stone block. So, in place of the costume number 118, we need a new variable, brush, for this sprite only. And for fun, we can begin by making it a slider, setting its range from 20, the first actual tile costume, up to, say, 200 for now, although we have a lot more, I know. I can then drag that to the first tile, 20. And we drop the brush variable in place of the number 118. Cool, let's see that in action. Click, click, and there is costume 20. Let's try another brush. Tile 77. Oh, the grass, of course. 116. Oh, nice, that's a fence. Yeah, so there are loads of interesting tiles to be explored, but a lot of them are hard to understand out of context. And wouldn't it be nice to see what tile we're going to place before we actually start painting with it? Well, not a problem. Come back up here to where we switch to the outline costume. Duplicate both the switch costume and the stamp block. And to show the brush tile before we actually place it, simply switch to the costume given by the brush variable, and now we can stamp it in place just like that. However, it can be nice to just fade the tile out a little bit. So set Ghost Effect to 25 before we stamp. Then we must remember to turn off that effect before continuing, so drop in a Clear Graphic Effect block before switching back to the outline costume. And it's testing time! So do you see how we have a faded version of the brush tile appearing at our cursor? That is sweet. And when we click, the tile becomes fully solid. Wow, we are making progress! Are you enjoying this? You know what though? A feature I often add to my editors is the Tile Picker key. That is when you press E over an existing tile, it selects that as the current brush, and we can paint with it. We can do this simply by adding to the bottom of the same paint editor script. If E key is pressed, then we set the brush to, well, the tile under the mouse, so item of grid. And we want the grid index again, GIDX. But watch out! This won't work yet because if you look, we are only setting GIDX when the mouse is pressed above here. We need to move this set GIDX out of there, moving it up to a more suitable position under the set GX and GY blocks here. That keeps all those all nicely together. And now, running the project, we can finally press E over an existing tile and switch quickly to that matching brush to continue painting. I love that feature. Also note, this is the fastest way to remove existing tiles. Pressing E over the grass, and you will find you can then paint over any tile to remove it. Very useful. But it's still a real pain trying to find any other tile you are after just using the brush slider variable. So we are going to now work on that awesome tile selection palette. Let's scroll back to the When I Receive Paint background receiver. So as well as painting the paint editor, we'll split the palette into its own custom block, Paint Palette. Run without screen refresh. Drop that in right after the paint editor. Let's find some free space for this. Okay, we'll start by painting a black rectangle to act as a background to our palette. We'll need to know how wide to draw it, so make a new variable, palette width, or pal width for short, for this sprite only. And set pal width to... Then we use a multiply, so you can say that the palette is 5 tiles wide, and multiply that by 32 of course. But we also want a small border around the whole palette area, so add to this 8 more pixels, that's 4 for each side. We'll use the pen to draw a thick line. So begin by setting the pen size to the width of our palette, pal width. Then position it using a go to XY block. Beginning at the top of the screen, that's 180. The X position, that wants to be halfway between the left edge and the right edge of the palette. Start at the right, 240, and subtract half the palette width, that's pal width divided by 2. We can check this looks right by, from the pen category, set pen color to and choose black, then use a pen down block, and right away a pen up block. If you run that, you should find we have stamped a large pen circle right here at the top right of the screen, positioned perfectly for drawing a thick line down the full right edge of the screen. Shall we do that then? Drop in a set Y to, just before we pen up again, setting Y to -180, the bottom of the screen. And did you see that drop down? Brilliant! Hey, do you notice though that with this right-hand panel in place, the game world no longer feels correctly centered on the player? What's more, if we dash over to the far right of the map, it can take a while, the level fencing is also broken now, in that the rightmost edge of the level is obscured by the palette area. That's a shame. Let's fix this. Click into the player sprite. Oh gosh, you know what? Before we fix the camera fencing, can we just fix this other highly reported issue? You know, when the project starts, the player can flick from facing forwards to facing in any other direction. Well, this is so easy to address. The problem is that we didn't initialize the player dir variable, player direction, when we set the player X and Y. So set player dir to 180. That's facing forwards. Bug squashed. Now, find the when I receive tick player script. Everything from the setCam X block onwards is to do with positioning and fencing the camera. So we'll split this off and make a new custom block for it. Name the block Move Camera and run without screen refresh. All these scripts can be popped into the define block and the Move Camera block placed from where they came. But we are going to want to change the camera positioning based on whether we are editing the level or not. So, using an if-else block, check if editor is equal to 1. Okay, just to be clear here, I am using equals rather than the greater than that I usually use, as I'm reserving an editor value of 2 to mean full screen editing, but we'll come to that later on. Next up, make a new variable, TMP, for this sprite only. We use this to store any temporary variable we might need for intermediate calculations. And in this case, when we are in the editor, set TMP to the width of this palette. To get that, from the sensing category, we need the thing of thing block. We first switch it from stage to our tile sprite. And then, and only then, can we find the variable named pal width. Yep, the palette width. This is a great block for getting values from other sprites, but it's not good for changing values. But that's fine because we don't need to do that here. In the else, set temp to 0. This means the panel is closed and has no width when the editor is not on. So first off, to center the player correctly when the panel is open, we need to scroll the level over to the right by half the panel width. Where we previously set cam X, we now sum player X with TMP divided by 2, half the palette width. If it's open, otherwise TMP is 0, and this will make no difference. Test that out. And you can see we are positioned smack bang in the center. That's looking smart. Hit that 0 key and ensure the position keeps toggling back to the center of each view. That's so cool. Now though, for the other fencing problem, right over here to the right. What you should see is that we will need to allow the camera to scroll over by an extra full panel width. If you move down in the code, this is the right-hand fencing, camx greater than. And we have a longish expression we are comparing to. We need to add to this the variable TMP. But rather than doing that twice, let's instead put a change TMP block before that if check, and drop in the Gmax expression instead. This has the effect of summing the two values and storing them in TMP, so now we can simply replace both those longer expressions with TMP itself. And there we go, the proof is in the pudding, and this is a rather yummy slice of said dessert. It works splendidly in both editor and non-editor modes. So good. So with all that resolved, we can move on to adding some content to our so-called tile palette. Click into the tile sprite and we'll continue to work on the define paint palette script. I'm going to use the GIDX variable to represent the palette's grid of tiles, setting GIDX to 20. That's the first tile costume. Now to position the first tile, set Y to 180. That's the top of the screen. And we move down by subtracting 16 from that. That's half a tile downwards, plus 4, the small border around our tile palette. Next, for the X position, set the X to, and working back from the right of the screen, 240, subtract pal width. And to this, we add the same half tile and border. 16 plus 4. And now we can switch costume to the variable GIDX. And yep, stamp. Phew. After all that, slap the green flag and see if we got the maths just right. If you did, you should find that the first tile costume has appeared majestically in the top left corner of the tile palette. Yay! That was the hard work done. To extend this out, just drop a repeat loop around the last switch costume and stamp, repeating for the 5 tiles wide we said we'd include. Then we just need to change GIDX by 1 to proceed onto the next costume, and change X by 32. Can I assume you know that's the tile width by now? Run the project. Now that is great. Can you appreciate the nice 4-pixel border we accounted for in our maths? That is working a treat. Next up, we'll extend this tile palette downwards too. So another repeat block, this time between the set Y and the set X, surrounding everything below. You'll find we can support a palette of exactly 11 tiles high, so repeat 11. After each row is completed, we need to add a change Y by -32. Yes, negative, as we need to move to the row below it. You'll note that we reset the X position before continuing to paint the next row. Run that now. And yeah, this is not bad. 11 tiles high fits perfectly, right? The only problem we have is that the tiles are looking like a little bit of a jumble. If we look at the original sprite sheet that these were split out from, you can see that the layout is actually really helpful in making sense of the tiles. We want to maintain this layout. So, in the same way we created the viewport for the game map, we need to add a tile skip after each row ends to move us on to the correct costume for the next row below. Before we change Y then, drop in a change GIDX. And the amount we skip is 1 row of tiles from the sprite sheet, this is 18 for me, but we then have to subtract from this the number of tiles already painted, and that was 5. Cool, and there you go, the tile palette is suddenly looking rather awesome indeed. But grant me this one more liberty, the black background to the palette is a little bit severe, and typically the area behind irregular shaped costumes is often shown using a light grey and white grid, like the one you see in the costume designer. It just so happens I have created one such costume just for this purpose. Costume number 3, named Mask. All we need to do is stamp this behind each other costume in the palette. So duplicate the switch costume and stamp, changing this time to the mask costume, and then pop it back in before the other costume is stamped. Run that now, and haha, that's sweet! Perfectly aligned, fit for purpose. You can see how well using the sprite stamping is helping us stay fully in control of our project, and can quickly make some crazy cool effects that would otherwise require a lot more work and expensive clones. Okay, so I'm currently painting with this flowery bush costume, but although I can see the same costume in the palette on the right, it's not indicated that this is the selected tile. Shall we fix that now? Start by dropping an if block in after stamping the palette's sprite, and check whether this was the active brush or not. That is, when GIDX is equal to brush. And then we just stamp the selection costume over the top, switching to that outline sprite, and stamping. But if we run that, you'll see we have a problem. Yes, it does highlight the selected brush, and we can change brush using the slider and see the selection change, but the outline is not fully drawing, only the top left of it. Do you know why? It's because of the order we are painting the tiles in the palette. We draw the first tile, then the outline if it's selected, and then we go on to paint the next tile, and this overwrites the edge of the outline. And the same happens below. To fix this, we need to paint the outline last, after all the palette tiles are painted. So drag out those painting blocks, and instead we'll make a record of the position of the selected tile for painting later. We'll use that GX variable, so set GX to the X position, and GY to the Y position. But in case we don't find the selected brush and set GX, we'll also need to set GX right up here before we begin the loops. And we set it to the empty value. Got that? Good. So back down to the bottom of the script. Now we can check if GX is greater than the empty value. This is only the case if we did find the tile. So simply go to XY, popping in our recorded GX and GY, and then switch to and stamp the outline costume. Wow, well that should do it. Running the project now, and yes it does. The outline is painted fully on top of the other tiles. Well, we're running out of time for this episode, but it wouldn't be right to conclude before we've added in code to actually select a tile from the palette, would it? Now, since we are stamping a full square mask behind each tile, we can simply use a touching mouse pointer for this. And we'll pop it just below the first stamp block, and we'll need an AND operator, so that we can check both when the mouse button is down and when the sprite is touching the mouse pointer. And if that is the case, then we just need to set the brush to GIDX, the currently painted palette tile. Let's check this out. So on first impression, this is doing exactly what we want. Clicking on a tile on the palette selects it, and we can paint with it as we like. Well, what could possibly be wrong with that? It seems to be working perfectly, right? Hide the editor palette, and you'll see. Do you remember us painting any of this over here? If not, then how did it get here? Let me give you a clue. In some free space, open the editor and click on the flower, rock, and tree stumps. And then walk across, and oh no! Do you see what's happened? Every time we selected a tile from the palette, it also gets painted to the level behind the palette at the same time. What a disastrous bug! And no, stop it! There's no way we are leaving this until next time. Come on now. Can you find with me the define paint editor script? This is where we position the mouse on the grid and replace tiles when the mouse is pressed. This needs to be fully disabled when the mouse is over the palette. So separate off all these scripts, and we'll check if mouse X is greater than, and we want the left edge of the palette, so that's 240, subtract pal width. If this is the case, then we can stop this script. You can see it works when the outline costume stops painting as we move over the palette here. Very neat. And if we click around on the palette, then if all is well, no tile will be painting behind. Nope, that's perfect. The only thing I might add is it's often nice to leave a little room for errors, so when detecting this palette edge, I'd be tempted to change it to 230 instead, giving a 10 pixel dead zone. But that's completely up to you. Wonderful. You know, I think we are there. Not that we haven't got plenty more features to cover. I'm very aware that we can't yet scroll our palette area to access the masses of extra costumes available to us. This we'll cover in the next episode. along with adding the exciting palette tile tracing feature that allows us to lay down large runs of connected tiles far more quickly. I love that feature. With luck, we'll also be able to expand our levels to feature not 1, not 2, but 3 layers of tiles so that we can experiment with layering tiles in front of the player as well as behind them for a more immersive experience. Wow, guys, I put a lot of effort into making these videos the best I possibly can. If you wouldn't mind showing your appreciation by clicking that like button, that would be amazing. And if you don't want to miss the next exciting episode, now is the time to make sure you've subscribed to the channel and toggled on that bell icon. Then you'll be sure to catch the next episode when it's available. Of course, if you want to be ahead of the game, then there's always my early access channel membership, which in turn helps support this channel further. So, as I wrap up, a quick shout out to my top supporters, the patrons and Inner Circle members. You are amazing. Thank you so much to Onjay, Chandra Buddy Wajoyo, Chicken Wives, Chris Naden, Cody Mugagumi, Creeper Craft, Dance Pop Corio, The Random Person, David Riziguri, Declan and Friends, Deskis Andreas, Elgato Games, Findora, Jasper the Game Master, Johnny Gaming, John, Jordan TRS, Joanne Corlos, Moralas Relias, Kellan Glenn, Mike Schmidt, Minecraft, Nikhil Reo, Rafula Tandel, Ray Winnie UK, Razkanaz, Sandra Paul, Shark, Shock59, Sophia Wang, TBD, Yosika Hernandez, and Yusong. So, until next time, thank you for watching. Have a great week ahead, and scratch on, guys!